Hi, I'm Bill Martin. One of my favorite technologies is not well understood by the general public. If you want to save money and go greener in your current or future home, stay tuned for more on geothermal heat pumps. They let you live a comfortable lifestyle with renewable energy. Run your heating and cooling by exchanging with the earth. You'll be glad you did. What geothermal heat pumps do. You are probably familiar with a conventional heating cooling system. It provides heat and cool through supply registers in your floor or ceiling, coming from a furnace. Room air returns to the furnace via ceiling grills before it is heated or cooled again, and brought back through the floor registers. A thermostat commands when heating or cooling begins or it ends. A geothermal heat pump system differs from a conventional furnace. We still have an air circuit through registers, grills, and the air handler that was part of a furnace. But a geothermal system does not burn fuel for heat. It gathers its heat from underground. The ground is the heat source, and in cooling, a geothermal heat pump rejects excess interior heat underground to its heat sink. The ground loop makes this possible. The concentration and transfer of such thermal energy is made possible by a working fluid called a refrigerant. Its name sounds like cooling only, but in heat pumps it works both ways. Let's follow the thermal transfer of energy more closely. We'll use a model of three colored cylinders that represent the heat source, heat sink, and the action of the refrigerant as a bridge between both. With a geothermal heat pump in the heating mode, thermal energy for the house comes from underground. Using its refrigerant loop, the geothermal heat pump accesses and concentrates heat from one location, the red cylinder representing the heat source, and delivers it to another location, the yellow cylinder representing the heat sink. Although the temperature underground is not high enough to directly transfer inside your house to satisfy you and your thermostat, the concentrating function of the heat pump raises this low-grade underground heat to a desirable temperature. 40-degree dirt can easily produce comfortably warm air inside your house. With the geothermal heat pump in cooling mode, we achieve interior cooling by transferring unwanted heat underground. Notice how the red and yellow cylinders have changed position. The heat source is now the house interior, and the heat sink is the ground loop. In all North American climates, a properly sized ground loop can accommodate all the house's rejected heat we want removed. Geothermal heat pumps are the most efficient air conditioners yet devised because instead of attempting to push rejected heat into 100-degree outside air, they can send it to 75-degree dirt. An additional benefit is that they operate on less electrical power than conventional air conditioners. In this map, the thermal stability represented by average annual underground temperatures also serves geothermal heat pumps well as they provide heating in the winter. You can see that average underground temperatures exist in a far narrower range than that of outside air in summer or winter. We have just reviewed what geothermal heat pumps do for us. Now let's look at how they do it. In cooling, we are dealing with a heat source and a heat sink. A ducted air circuit inside a too-warm house transfers its heat to the heat pump's refrigerant loop. The refrigerant concentrates this heat via a compressor and transfers it to the ground loop, where it is pumped through piping that is buried at least 6 feet under the earth. In each cycle, the ground loop reduces its temperature 5 to 8 degrees before returning to remove another load of heat. This example shows air circulation of 950 cubic feet per minute and a ground loop of treated water circulating at 9 gallons per minute. If you noticed a wide difference between these numbers, it's because water is over 3,000 times as dense as air. Therefore, we can dump lots of BTUs into a smaller amount of liquid and easily transfer this heat. Larger heat pumps would feature larger numbers, and smaller ones would be less. In heating, we are still dealing with a heat source and a heat sink. Notice how the red and yellow cylinders have again changed position. In this case, an interior thermostat sensed a need for additional heat. It called on the heat pump to provide it. Pumped circulation of the liquid ground loop begins, and low-grade heat is transferred to the heat pump's refrigerant, where a compressor concentrates it to a much higher temperature. This hot refrigerant transfers its heat to the ducted air circuit inside the house. Having transferred the ground loop's heat to the air circuit, the refrigerant now returns to meet the ground loop at a much lower temperature, ready to transfer another load. Each time the ground loop returns to meet the refrigerant, it does so at a temperature about 5 degrees higher. This thermal transfer cycle continues until the thermostat is satisfied. The major advantage of a geothermal heat pump system over all of the conventional alternatives is that it's 100% renewable. The heat you extract will be replaced next winter, waiting for you to transfer once again. It's even likely that a portion of the heat you reject underground in summer slightly boosts the ground temperature before you begin your heat removal at the beginning of next winter. Geothermal heat pumps are the greenest mechanical heating and cooling systems available today, according to the EPA. Also important to homeowners is that no mechanical equipment resides above ground, subject to weather or vandalism. They are protected, quiet, and clean. As U.S. electrical utilities generate their power with increasing fractions of renewable resources instead of fossil combustion, everything required to run a geothermal heat pump will become completely green. In a regulatory environment that increasingly calls for zero net energy in new buildings, the geothermal heat pump is the only technology that can work together with solar-generated electricity to handle all thermal loads in a building without producing greenhouse gases. True ZNE means that on an annual basis, all energy consumed on a building site is equal by the energy produced on that same site. Thank you for letting me share my passion for this technology with you. I hope that you will consider it for your next building or retrofit project.